All right, welcome back to the third part of our video series. So now we have the buildings in our map, and now we would like to define the network. So we can click here on draw pipe. We can go then along the street, for example, and draw the district heating network. So for example, like this here. And there's also a possibility to import directly the network from the streets, and I would like to show this as well. So if I delete the pipes here, sorry, if I click on select all pipes on the left-hand side and then click here on delete 8 pipes, then I will show you how you can also load the pipes directly from the streets. So if I click here on define area for data retrieval and I do not select the load buildings, but only load street routes, then you can go with the shape here around the streets that you would like to import. Then click on load data. And now it would import the pipes or draw pipes along the street. We can now connect the buildings to the network. So if I click on one of the buildings, then we can click here on connect to network. Then it would connect it at the smallest distance. And if I click on multiple buildings with the right click, then I can also connect them directly to the street, to the nearest point of the street, or of the pipe, sorry. And if I click on the left-hand side on all buildings, then we can also connect all the buildings directly to the network. We can also do it manually. So if I delete this section here and I say, okay, we would like to have the pipe on this side here, then we can also draw the pipe manually into the map. So let's go a little bit down here because we find the settings in these three buttons. If we click on heat network settings, we have here the heat losses. The heat losses are calculated for the different pipes based on the insulation thickness and so on. And we have a surcharge for the fittings, so 20% in this case. For fifth generation district heating and cooling networks, you can also neglect the losses. That's also a possibility. And the second parameter is the network temperature. That's, I would say, the most important parameter. So you can say that it should be a constant temperature. Then you can define the temperatures here, supply and return temperature throughout the year. If you say we would like to use a sliding temperature curve, then you can click here on sliding and then define temperatures. And then you find here the ambient air temperature and yeah, this typical supply profile that you would like to have in many cases. You can also upload your own profile if it's something very special. And then we have some more parameters for the sizing of the network. One is the design criteria. You can choose if you want to design the pipe diameters based on the pressure gradient and or the flow velocity. You can define the diversity factor. There are different methods that you can choose from, and you can also choose your own profile if you want to for the diversity factor. We have some ground parameters to calculate the ground temperature. And we can select the heat carrier fluid in case that we do not have a normal district heating network, but maybe a fifth generation district heating network. Then you can select here also brine as the heat carrier fluid. If I click on visualize profiles, then we would see on the left-hand side the ground temperature, the supply and return temperature. And here on the right-hand side, we see the diversity factor based or depending on the number of buildings. In addition to these general settings, we have some hydraulic settings in the second button. So if I click on this one, we find, for example, the setting circulation pump. Normally, we would use the central pump, but in case of fifth generation district heating and cooling networks, we can also use decentral pumps. We have some information about the pressure losses. So, for example, percentage for the fittings and installations. In addition to the normal flow pressure losses in the pipes, we have substations and can define the pressure loss in the substations. We have the pressure losses for the energy hub. And we can also define some information about waste heat feed-in. So in case that we have prosumer buildings in the network, we can say what is the temperature difference with that the prosumer buildings used to feed in the waste heat. So yeah, and the last option or the last window is here the pipe parameters. If we click on this one, we see here the parameters that we are using for the pipe dimensioning. On the left, we have the pipe type that we can select. So it can be a steel pipe, single pipe, could be steel and a twin pipe. So supply and return within one case. And then we have the plastic configurations with single and twin pipes, and also for the case of fifth generation district heating and cooling networks, we can also use uninsulated plastic pipes. We have a library here that we can use to import directly some data for our table. You can also define your own data if you want to. You can export it and import it. We have the pipe costs that you can define. So if I click on this one, then we see here the based on the diameter, we can define the costs for the pipes as well as the cost for the installation. And these are then used to calculate the overall investment costs for the district heating network. So yeah, you can change all the parameters here. You can directly click in the boxes and then change the parameters. You can also remove different parameters depending on your preferences, and also change the design criteria, in this case, the maximum pressure gradient, as well as the maximum flow velocity. All right, so these are the parameters that we can have for the network itself. In the next part, we will then simulate the district and then see what results we can get from the simulation.